Hi, everyone. Thank you so much for joining today's AuntMinnie webinar, Unlocking Smarter, Faster, and Safer MRI with SwiftMR. My name is Gina Park, and I'm the Chief Strategy Officer at AIRS Medical, and I'll be serving as your moderator for today's session. Before we dive in, let me quickly walk you through today's agenda. We'll start with introductions and provide brief overview of SwiftMR. And from there, you'll hear three different perspectives on how SwiftMR is transforming MRI practice. First, how it's improving efficiency and throughput. Then, how SwiftMR is being used to build premium whole body MRI services. And finally, how it helps to enable safer, smarter imaging from technologist standpoint. We'll wrap up with a Q&A session, so please feel free to drop your question in the chat throughout the presentation. Let's start by introducing our speakers for today. We're joined by Dr. Dyer, who is the Chief Medical Information Officer at East River Medical Imaging in New York, and Dr. Eber, co-founder of 3T Radiology and Research in Florida, and finally, Chris Triolo, Technical Coordinator and MR Safety Officer at HMCA. Together, they'll share their perspective on how SwiftMR is helping providers improve efficiency, build new services, and deliver safer imaging. Now, let me give you a quick overview of SwiftMR. With SwiftMR, scan times can be reduced by up to 50% without compromising image quality. This means more patients scanned per day, shorter appointment slots, and better overall patient experience. So, what are the tangible benefits of cutting MRI scan time by up to 50%? For some sites like 3T Radiology, it meant generating over $100,000 in new revenue within the very first month and even creating a brand new whole body MRI service line. For others like Raya Radiology, it meant avoid $1.5 million scanner purchase and saving another $500,000 in OEM upgrade costs, all by getting more out of the scanners they already have. At East River Medical, scan times were reduced by 36%, while at MedStar Georgetown, shorter exam slots improved overall capacity management. The bottom line is this: with SwiftMR, sites become more efficient, more profitable, better positioned to meet patient demand, all at a fraction of cost without any disruption to their existing workflow. SwiftMR has grown rapidly both in the US and around the world. Globally, we now have over 1,000 customers, with more than 300 here in the United States. What's exciting is that our adoption spans across the spectrum, from large academic hospitals to multi-state enterprise radiology groups and outpatient imaging centers. You may be wondering why so many providers, from academic hospitals to outpatient imaging centers, choose to adopt SwiftMR so rapidly. It comes down to 5 key reasons: superior image quality, clinical validation, strong positive ROI, 24/7 customer support, and the fact that all updates are included at no extra cost. Our customers are consistently seeing these benefits in their daily practice, and that is why the adoption has been spreading like a wildfire. To wrap up, SwiftMR stands out because of its comprehensive coverage. It works across all body parts, sequences, and wide ranges of scanner ages, with no software or hardware upgrades required. It delivers true 3D super resolution, offers flexible customization for every sequence, and is compatible with all scanner vendors. In short, SwiftMR delivers faster, sharper, smarter MRI for everyone. Now that we've covered what SwiftMR is all about, let's hear directly from our customers about how it transformed their practice. Our first speaker is Dr. Tim Dyer, who is the Chief Medical Information Officer and Head of Musculoskeletal Interventional Services at East River Medical Imaging, and Clinical Assistant Professor of Radiology at Weill Cornell. He'll be sharing his perspective on how SwiftMR has transformed MRI efficiency in a busy outpatient center.
I'm Tim Dyer, radiologist and Chief Medical Information Officer at East River Medical Imaging. And today I'm going to be talking to you about our use of SwiftMR. So I just want to talk to you a little bit briefly about where I come from. As I said, I work at East River Medical Imaging. We're a private practice based in Manhattan and Westchester County, just north of New York City. We're surrounded by a number of large tertiary care hospitals, Memorial Sloan Kettering, Hospital for Special Surgery, New York Hospital. So it's very important to us that we are at the cutting edge of technology and providing quality studies to compete with those large hospitals around us. So we had a couple challenges that we faced over the past couple of years, especially at the beginning of COVID. We had a number of staffing challenges. So a lot of our techs decided that they were going to get up and move out of New York and move down to Florida. So as a consequence, we really had to do a whole lot more with much less staff. Um, as all radiology practices we have issues with patient discomfort. We have patients who don't want to go in the magnet because they're claustrophobic or anxious about going in, or are in so much pain that sitting in an MRI for 30 minutes is very difficult for them. And then, of course, as I think every radiology practice is having, we're having a lot of issues with cost and revenue. Um, as I'm sure everybody can understand, inflation has gone up 25% since 2020. But I don't have any insurance companies coming and knocking at my door telling me that they're there to raise my reimbursement rates. Um, so we face a lot of challenges because our revenues are staying stable, but our costs are obviously going up. So we need to be creative. So using AI acceleration with our MRs was one of those solutions. So we first started out with one vendor in 2020, and our purpose at that point was really to provide our technicians with a little bit of a break. So as I said, we were really working the technicians who stuck around very hard. They were doing a lot of scanning. Um, and what we really wanted to get out of that first AI solution was just a little bit of time. So taking a study from 30 minutes to 25 minutes was a big win for us, because that just allowed the technicians to have a little bit of breathing time between studies. But as time went on, we started to really want to change our scan time from a 30-minute time slot to a 20-minute time slot, so we could fit more patients in each machine each day. We did use a OEM solution next, which did well, but ran into some problems again with getting the time slots to be short enough that we could switch from a 20 or a 30-minute time slot to a 20-minute time slot. About 2 years ago, we switched to SwiftMR, and we found that we were able to change our time slots from a 30-minute time slot to a 20-minute time slot for a majority of our studies, which was really a big game changer on a multitude of levels. So as you can imagine, the math is pretty simple. We theoretically had a 50% increase in scan volume, had a pretty dramatic overall reduction in our scan times, and could accommodate a larger number of patients on each MR machine each day. And with that, because we're getting more patients coming through on each machine, we've really seen most of our backlogs go away. Swift has really been just an excellent experience of dealing with the company. So the technology is obviously important and needs to do a good job at what you purchase it for. But you've got to remember, when purchasing any of these technological solutions, that customer support is important as well. So you want a company that's going to be responsive to your problems, and when you do have problems, get fixed very quickly. And I can say I've had absolutely zero issues with Swift since we've installed it. I think we had one issue on a software update that took us down for maybe an hour or so, and I sent an email off to customer support. They were on it immediately, fixed the problem immediately, and got us right back up. Unfortunately, during that hour, all we had to do was go back to our original protocols and just scan as we were before. So it didn't really have any material effect on our workflow that day. So obviously, there's a number of people that we need to satisfy when we install new technology in a radiology practice. First are the technologists. As I mentioned, we really had a real challenge early in COVID. With the number of technicians that we had, we just didn't have a sufficient number of technicians to scan the patients that we needed to scan. And Swift, we found, really helped from a number of different perspectives. I was actually surprised about this. So the solution that we had prior to Swift I only learned later, after we had switched, that the technologists were very frustrated with, because they were having delays when they sent off a study to be processed, and couldn't adequately look at the study to decide if something needed to be repeated. But since we've switched to Swift, I've heard from the techs really nothing but good things. The processing happens incredibly quickly, so if something did get screwed up, studies can be, or sequences can be repeated very quickly. And then interestingly, the techs really appreciate it because it actually makes the patients a lot happier. So because the tests are so much quicker, patients are happier, they're less uncomfortable, and when the patients are happier, the techs are happier. So this was some quotes from our lead tech, and basically saying that he likes Swift all the way around. Patients, obviously, another important quote unquote customer that we're satisfying with new technology. As everybody knows, we have a number of patients who are claustrophobic. They don't like being in the magnet for a long period of time. So cutting down studies to a much shorter period of time is really a game changer. As you can see, I put a quote down here from a patient of ours, very claustrophobic. He was coming in probably every 6 months to a year to get MRIs of the lumbar spine. And I brought him in after we installed SwiftMR, and he was just blown away because his MRI of the lumbar spine went from being 20 some minutes down to around 10 minutes. And for him, even being claustrophobic, 10 minutes was an easy amount of time to sit in the MR. And then, of course, we also have patients who are coming in who have a lot of pain, so that big time delta also helps with them. Workflow, big change, obviously, as well. That was really one of the reasons that we implemented AI acceleration. So we were able to move the time slot from a 30-minute standard time slot for most of our exams to a 20-minute time slot, which, of course, just doing the math means instead of doing 2 patients every hour on the machine, we can get 3 patients every hour on the machine. So makes it a lot easier for throughput. We can scan more patients in the same amount of time. So for every tech hour, for every machine hour, we're scanning 50% more patients. The other thing it allows us to do as well, because we get a lot of urgent add-ons from the surrounding hospitals, is to open up those little time slots to be able to sneak someone in, so they're not waiting days and days and days to get an urgent scan done. It also allows us a lot more flexibility because the scans are shorter. So if a patient does need a little bit more attention or is having problems on the machine, the techs don't get stressed out because they know that next study is going to be able to fit within the time slot, and it's going to be easy to just get back onto schedule. I've got a quote on the right side there from our chief operating officer, previously administrative director of radiology. Basically kind of summarizing what it's like with those faster scan times. You're basically getting a patient on, scanning, getting off, and then getting the next one on. So it just churns throughout the day. So here you can see some of those reductions and how they affect our workflow. So we've got reductions anywhere from 20% with a shoulder, getting that actually under 10 minutes, to 54% with our hips, where we changed it from about 23 plus minute scan time before Swift to just over 10 minutes after Swift. So you can see all of these times there. Even though we're running a 20-minute time slot, we're well within that 20-minute time slot. We're not just at that 20-minute time of scanning where we're going to have problems getting the patients in and off the room and create problems with the workflow. We're really under that time, the 20-minute time slot. And then, of course, the radiologist, who this is obviously important to as well. I'll just give you a little anecdote. When I put this in, we had everything installed. We had gone through all of our troubleshooting with Swift. We were pretty confident that everything was going to start working. And I was having a little back and forth with the guys who were installing it. I said, when should we start it? When should we start it? I said, let me talk to the radiologists. And I was kind of slow in getting around to the radiologist. And it turned out they just had turned it on without telling me, because they thought I gave the okay. And not a single radiologist complained to me. Not a single one says, hey, what's going on with these images? So from the radiologist perspective, there's really zero difference between what you're seeing after AI acceleration and what you've been seeing before. And I can tell you that that's definitely not the experience that I've had when I've done other technological changes. Radiologists tend to be fairly fickle. So going through one of these upgrades without having someone complaining to you that it's not something that they like is to me a big win. And I think anecdotally, I've also had the radiologist tell me that because each of the sequences is so much shorter than before, they're seeing a lot less repeats for motion artifact, because we're really down around that just few minutes for each sequence. So I'm just going to go through a little bit of a show and tell just to give you an idea of what we're dealing with here. So this is our conventional scan on the left. On the right is the exact same thing, accelerated with Swift. This was done on a 1.5 Tesla. So, to my eyes, it's a virtually identical study. You can see there's a little chondral defect in the trochlea there. Just as well categorized or characterized on the conventional scan as with the AI accelerated scan. But the impressive thing is we saved 66% of the scan time, right? So our scan time was 3 minutes before. We've got that down to a minute. Same thing here. Again, on a 1.5 Tesla GE magnet. On the left, the conventional scan of the lumbar spine. On the right, the accelerated study. We're about 28% faster here, so not as dramatic of a time savings. But you can imagine if your back looks like this and you're being scanned for a minute as opposed to 2 minutes, it's going to be a big win. This was some work we did on an open MRI that we had. And again, you're seeing a big time savings here. So conventional scan on the right side of a shoulder, or on the left side. On the right side, our accelerated study with Swift. I mean, again, to my eyes, everything looks basically the same there. All of the pathology can be identified on both scans, but you're having a huge, huge time savings. So this is another example with the open MR. As opposed to massively decreasing scan time because quality on the open MR is not so great. You can also really focus on improving quality. So these scan times were both the same, but on the right, you can see that the AI acceleration was applied to that sequence. And you can see the massive difference in quality here. You can really much better see the chondral wear over the femoral head and acetabulum on the accelerated scan. So Swift was kind enough to present me with some of their product enhancements that are coming up over the next year or so. I won't go into detail about these things. They're obviously something your Swift representative can go into. But I just want to point out something important with Swift. Because of the way it's set up as effectively a subscription model, all of these enhancements that they're constantly putting into the algorithm just go along with the subscription. So there's no additional cost to upgrade to get their fancy new thing that they're rolling out. It just automatically gets put in. These things get updated. They do a lot of testing on it. I've never, except for one time, had any issues with any of these updates that they've rolled out. So just to summarize, when we installed Swift, we had an immediate return on our investment, right? Because from the moment we had it in and had it going, we could go from 2 patients an hour to 3 patients an hour. Massively reduced our scan time. So if we just look at the time we're actually scanning, we got about a 35-36% reduction in scan times. Customer support, which I think is really, really important. I got to tell you, as CMIO, I'm dealing with a lot of tech installations, and some companies are really easy to deal with, like Swift. Other companies, not so much. And I really search out those companies that have good customer support. I think is really important. As important, I would say, as the technology. And then again, as I mentioned, constantly getting new features and upgrades, and those are just rolled right into the product. There's no additional payment for upgrades. And I love this quote. I'll just kind of finish up here from our lead tech. He says, if you have a chance to implement SwiftMR, I don't see any reason why you wouldn't. Totally unprompted, but totally agree. We've been really satisfied with it. It's really changed the way that we operate as a radiology practice.
Thank you, Dr. Dyer. Next, I would like to introduce you to Dr. Eber. Dr. Eber is the co-founder of 3T Radiology and Research in South Florida. He's a board-certified radiologist in both diagnostic radiology and nuclear medicine, and also a past president of Florida Radiological Society. He'll walk us through how his practice has built a successful whole body MRI service line with SwiftMR.
Hi, everyone. Thank you so much for having me. My name is Dr. Daryl Eber. I am a board certified diagnostic radiology and nuclear medicine physician. I'm one of the co-founders of 3T Radiology and Research, which is one of the leading outpatient imaging groups in South Florida. So what I want to talk about today is building a premium whole body MRI service, how we're using SwiftMR in our practice to really enhance and capture whole body MRI studies. So a little bit about my practice. The name of our company is 3T Radiology and Research. We have 5 outpatient centers in South Florida. Hopefully, within the next 2 years, we'll have at least 8 outpatient imaging centers in South Florida. We're a physician-led practice. We're known for pioneering patient-first imaging, including whole body MRI. This is actually my partner, Umberto Carrion. He's my co-founder. So we both have extensive experience in outpatient imaging and radiology. And we actually work really well together. And one reason why we decided to partner is we felt that it was extremely important to empower patients, take control over their healthcare. We also like inserting ourselves and helping out with patients' healthcare, not just in radiology, but make sure they go all the way through the healthcare process. And when we looked at a whole body MRI, although at first we were a little bit skeptical about it, we realized that this was really could be an important tool that could empower patients to take control over their healthcare and also longevity. But how did we go about with whole body MRI? We have kind of an interesting history with whole body MRI. Initially, we did a partnership with one of the third party providers, which really did customer acquisition for us. And what we found was that just wasn't the right fit for us. A lot of it had to do with the patient scheduling. So when you look at the third party vendors, these are like, some of the other strictly focused whole body MRI facilities and some that do like you can partner with in your facility. They really took control over the schedule, and it became very difficult to be adaptive, especially if you need to get stat patients in. And then also there were problems when patients wouldn't show up. So we kind of wanted to take control over that. So the way that we're doing it now is we're the ones that are booking the patients, and we're using SwiftMR whole body program to really empower us and empower the patients to have the best experience possible. The other thing about the third party was that they had their own protocols that we couldn't change. We couldn't adapt. It didn't matter, if the patient had a certain medical history. It became very cumbersome in certain circumstances, particularly when, as a physician, I learned that the patient might have, risk factors for certain things. I couldn't even change the protocol, and that was very difficult to deal with. But when we do it ourselves, we have complete control over the protocols and what we can do for that patient. It almost provides like an individualized care for that patient. Also, the other thing is that the results are shared through the vendor, and then the vendor is the one that kind of takes control over communicating that to the doctor and the patient. But with us, when we're, in complete control over the whole body MRI, we actually get to communicate with the doctor. I communicate personally with patients many times, and it provides us with not just better care and a long-term relationship with the patients. It also allows for extra revenue opportunities. So again, the advantages of doing the whole body MRI, in your facility, quote unquote, in-house, rather than using a separate vendor. You get the real-time scheduling. So like I said before, when you can take control over cancellations, make it more adaptive, you can work with the patients in case they need to move it a little bit, or you need to squeeze somebody in if they're running late. You have complete control over that. The other thing is the tailored protocols. So again, based on what the communication is with the patient or the patient's doctor, or risk factors, or even thinking into the future, if they have, some genetic analysis or even some of the liquid biopsies, you can tailor the protocol specifically for what their risk factors are. The other thing is that the continuity of care, we found this to be, very valuable. So if a patient comes in for a regular MRI, maybe they have back pain, they come in for an MRI of the lumbar spine, they come in for MRI of the knee, shoulder, abdomen. Even in our scheduling system, what we've been able to do is we've been able to communicate to the patients, hey, listen, we also do a whole body MRI. And so it gives us touch points, and patients get to have regular, MRIs and scans with us, but also get to do some of the longevity scans like the whole body MRI. And so the reverse is true too. If patients come in because they hear about us for whole body MRI, then they like us, they can come and do some of the other studies with us. The other thing is that instead of sharing that revenue with the third party vendor, we actually get complete control over that revenue. So we're not sharing any of the profits. We're, safeguarding our reputation and our clinical standards, and that's extremely important. The other thing, like I said before, is it allows us opportunities to potentially upsell additional services when they're clinically appropriate. There's a number of different algorithms that are coming out, which we can address towards the end of this talk, that would allow us to kind of, upsell patients, not just getting the regular whole body MRI. So when you control that workflow, you're really delivering end-to-end care. They're getting the correct protocol. You're in constant communication with the patient. It's a seamless experience for the patient. And then also we're responsible for delivering the results, which ultimately patients want answers and not more questions. And we felt that was really important for us with whole body MRI. And again, that goes directly into the improved diagnostic interpretation. So if we're in control of the protocols, we can get higher resolution images. We work with SwiftMR to improve the images, also to make the scan faster, which is really important. And again, that allows us to find subtle abnormalities that may not be detected with some of the protocols from the other vendors. Again, reducing scan times is important. The whole body MRI, we're trying to get it as short as possible. The patients could be in the scanner anywhere from 45 minutes up to an hour. And it's a long time to be in an MRI. It's a very stressful environment and it's kind of tiring, but also the times before and after the exam. So patients really are spending a lot of time, going through this. And then the other thing that's really important is, how is this service being looked at by the patients? So we want to deliver as much value as we can to the patients. So the patients want to feel like they're getting something for their money, that there's value in this. So they're getting answers. The obvious thing is they want to get something that's completely negative, but you have to have confidence in the entire delivery of that study to tell them, listen, you don't have cancer, you don't have signs of lymphadenopathy or a mass or something like that. So it's really, really important that we do this right. So with SwiftMR, it really helped us because, again, when we talked about delivering end-to-end care, we use SwiftMR plus some of the whole body protocols that we were able to develop in-house. We're really gaining full control over the workflow. It's super important for everything else that happens downstream. That improves the diagnostic interpretation. We have the custom protocols in-house. We're using SwiftMR. We're getting sharper images. We're getting them faster. And so if we're getting better quality for the radiologist and a faster, image acquisition for the patient, we're both winning in that scenario. The other thing is, overall, that's the reduced scan time. So doesn't just help the patient so they don't have to be in the magnet, but it also helps our center. So, we've been able to shorten the whole body MRI exam by up to 50%. So what that means is we can potentially see more patients per day, generating more revenue for the center, not just helping the patient with making it easier and shorter for them. And then again, going back to the value for the patients, it's something that we take very, very seriously. So we want them to come out with answers, really gain insight into what's shown on the MRI, what's going on in their body, and then helping them form an action plan so they can take care of certain things or follow up. So when we took a look at our protocol with SwiftMR versus some of the other third parties, we were kind of surprised. Our protocol, we're acquiring over 5,000 images versus 2,500 images with the partnership that we did previously. And again, when you look at the revenue share, we basically were getting 50% of the revenue that was being taken from the patient. And then with using SwiftMR, we're basically getting all of that. Again, the scheduling control, we had some control over the schedule, but once the patient was scheduled, it was kind of locked in. There was really no maneuverability. But if we take over the schedule, it allows us a lot more flexibility. And also, we have certain protocols in place in case the patients cancel within a certain period of time, so we have to protect our downside risk. The other thing is the patient experience becomes fragmented. Like, okay, I'm going to this center, they're doing this, but I'm talking with the technologist, but they're not really part of the company. And then I'm getting my results with this other company, but I didn't really interact with them. So it was very chaotic and fragmented with SwiftMR and having our own protocols. They come to us, we take full responsibility, and then we deliver the results to them and their doctor. So again, just going over this, the big SwiftMR difference that we found is we're acquiring essentially double the amount of images in the same scan time as some of the third-party providers. Not only that, but we're also getting them in higher resolution, which is super important. The revenue that we're getting, keeping 100% of the revenue, not just that, but it's allowing us to offer additional revenue streams to the patient, so certain upsells. Also, our goal is to always keep the whole body MRI less than 1 hour. That's important for the patient, and that's also important for the center. I just want to go over a few images just to show you some of the images that we've acquired for whole body MR. And again, the image quality is better, and that having a higher quality image will definitely allow us to make a better diagnosis. So you can see here we have our sagittal T1 weighted brain MR. We have the axial and coronal, and you can see how high quality this is. This was done on our 3T Siemens Skyra, and patients also, a lot of times they really haven't seen the images, and when I do the consultations directly with them, they're pretty much blown away with the images. And really using SwiftMR makes the image quality sharper, and not just for higher quality for better diagnosis, but also more marketable. And again, here's our FLAIR series, both in sagittal, axial, and coronal, and you can see the quality. This is really important because this is one that I like talking with patients about. As brain ages, it's really important that we go through the FLAIR series. We show any kind of small vessel ischemic change. So the quality in this series is super important. Here's an axial T2 weighted fat sat view of the abdomen, and you can clearly see the high quality of this study. And unfortunately, I can't scroll through it, but look at the sharp outlines in the spleen. The other thing is, when you go through this, a lot of times pancreas is a little bit more difficult to see on some of the T2 weighted series versus T1, but the pancreas shows up really nice. Obviously, the liver does too. So this is extremely helpful. And then here's our T1 weighted. This is just a bread and butter T1 weighted series. Again, quality is very good, and it improves upon the quality that our machine's already acquiring. Here's the coronal T2 weighted fat sat. This is obviously can be a difficult series, particularly when you do whole body and we stitch all the series together, but the quality has been great. It is a little bit sensitive to patient motion, but so far it's been extremely helpful. And then when we go on to the next one, this one is very important. This is a whole body diffusion weighted image, and these are can be extremely difficult to acquire and get good quality. But I mean, if you look here on the right, you can see that the whole body diffusion weighted series in coronal is really unbelievable. And then also we'll do 3D MIP, which kind of looks like a PET scan, and that's something I like showing the patients. And also we can point out the lymph nodes. We can look for masses. This is becoming, especially in the literature now, the diffusion weighted whole body MRI is very, very important when you're looking for early cancer detection. So the big takeaways, again, I really want to reiterate this because it has been a game changer for us. So again, taking control over the workflows, super important to do that all the way from the beginning to the end. The other thing is that the improved image quality and faster acquisition are super important for diagnosing appropriate abnormalities. And also it's important for diagnosing, calling it a negative exam. That's really important. And that's, really the ultimate goal of doing this study is to give that to the patient. That's what they want. That's what they're hoping for. But if there is something, you really need to have high quality images to protect yourself and also provide for the patient. Then also acquiring a larger data set. We can do it at essentially the same time period that the other vendors do, and we're acquiring 2 times the images. The increased profitability, we can get more people in during the day if we can keep the whole body MRI less than 1 hour. Also, we have other potential revenue streams. And also, the other thing that's really important is this is scalable. So we've been able to take our whole body protocol since we took control over it, and we've been able to implement it not just in one center, but we now have implemented it into all 5 centers we have in South Florida. And then the other thing that's really important is, since we're taking control over the entire process and it's an efficient process, we're able to provide same day answers to patients, even with direct consultation with the radiologist. So there's some interesting things on the horizon for SwiftMR. Again, there are numerous, this is what I referenced at the beginning. There's some interesting patient-centered care and reporting algorithms that are going to be introduced. Obviously, the whole body MR protocol, which we have now to increase the efficiency and quality of the whole body MRI. The next is to provide a patient-centric report. So allowing the radiologist to still provide the report that they do. There's standardized reporting done through the ACR. There's recommendations through the different societies. So the radiologists still have to report the way they need to report, but to take all the reports in our practice, we have multiple radiologists read specific areas because we want to make sure that we have the highly trained subspecialty radiologists kind of take control over their specific areas. So we provide the best interpretation for the patients, but to aggregate all of that into a patient-centric report that's easily digestible and understandable is super important. And it's also not just for the patient, but also for the referring doctors. Then also, there's other things that we're starting to work on with SwiftMR, such as the brain health report, which can look at brain age, brain volume, cognitive risk markers. It's really exciting, and that would be again an additional revenue stream. Then looking at spine health report, look at alignment, disc degeneration, curvature tracking, early degenerative change. That's all very, very important. And then ultimately looking at more of a metabolic health report. So looking at body composition, body fat percentile, muscle mass, liver fat analysis. All of these really can increase the total margin that you get for having the patient come in for a whole body MRI. It's really exciting. So the direction that I'm seeing now in the market is, when we originally did the whole body MRI, we actually had a pretty big push from patients and from, it started out in the concierge doctor space, but that's since moved to more patient directed, meaning that the patients are becoming more educated on a daily basis. This could be through podcasts or communicating with friends and family or just advertising on social media. Like, the word is getting out that whole body MRI is part of an umbrella of services that you can get to kind of take control of your healthcare and to start monitoring it and make sure that you're going to be in the best health you possibly can and extend your longevity. So I see that patient-directed healthcare is, growing month to month, week to week. I see more and more patients. And not only that, but there are more and more companies that are advertising directly to patients. So the best thing that you can do is have a protocol, have a plan in place, have everything that you can do to capture that market, because they will come, even if you don't seek them out, patients will come to your centers and will ask, hey, do you offer whole body MRI? Do you offer these other products that I'm seeing advertised on social media, that I'm seeing on TV, that I'm seeing on podcasts? So having a suite of the whole body MRI, the brain health, spine health, metabolic health report, and also, patient-centric services, including the actual finalized report, are absolutely critical for a successful business moving forward.
Thank you, Dr. Eber. I would now like to introduce our last speaker. We have Chris Triolo, Technical Coordinator and MR Safety Officer at Health Management Company of America, HMCA. HMCA is a large multi-state imaging group located in New York and Florida. With more than 20 years of experience, Chris will share the technologist's perspective, how SwiftMR helps improve workflow efficiency and patient safety.
Hi, I'm Chris Triolo, Technical Coordinator at HMCA, MRI Safety Officer. Today we'll be talking about MRI safety and how you can leverage the advantages of SwiftMR for safer and smarter imaging on patients, specifically patients with implants. So there are three main energy sources in MRI. Today we're really going to focus on RF exposure, the other two energy sources being the magnet, which is a constant that you cannot change, and gradient magnetic field, which is easily mitigated by changing your gradient pulse type. The RF pulse being the main safety factor for the patient. We're going to talk about RF in three different ways: SAR, specific absorption rate; V1 plus RMS, and specific energy deposit or specific energy dose. SAR, the specific absorption rate, is the measure of RF energy absorbed over a set period of time or a set duration of the scan. The importance of SAR: the human body absorbs the RF energy as heat. Of course, we all know the energy is transmitted into the patient, absorbed by the patient, given off as signal. The residual energy builds up in the patient as heat. That's where it becomes a risk to the patient or the implant. Excessive RF exposure can cause tissue heating. It can induce currents in the implant, and it can cause burns to the patient. So this is going to be our main safety concern. MRI systems all are set to monitor and limit SAR based on guidelines by the IEC, FDA, and ISO. And this is going to be something that is scanner and manufacturer dependent. We'll get into that a little bit later. So what is SAR? SAR, or specific absorption rate, is a vendor-specific calculation of RF energy absorbed by the patient during the exam. SAR is measured in watts per kilogram and reflects the calculated amount of energy that is being retained by the patient during the pulse sequence. V1 RMS is a vendor-neutral mathematical equation that determines the amount of RF energy put into the patient. V1 RMS and SAR do directly correlate because as you increase the amount of energy deposited, you increase the amount of energy absorbed, so both will go up. V1 RMS is the more currently used FDA labeling for devices, since it is consistent among manufacturers and is something that is calculated at the beginning of the exam instead of during the exam, so the tech can make an informed decision on the amount of energy being put into the patient. You can think of this way. SAR is like a governor put onto the magnet to make sure that you don't go too fast and that you don't harm the patient. It's calculated throughout the duration of the exam, and when you hit a threshold, the scanner will either stop you or slow you down. V1 RMS is a value given at the beginning of each pulse sequence, so you know how much energy is being deposited into the patient, and so that you know sequence by sequence you're staying within the threshold for the given implant or for the patient's condition and how they thermoregulate. So SAR is the manufacturer's way of keeping the patient safe. V1 RMS is a way for you to keep the patient safe. So the RF pulse and energy deposition. The RF pulse acts like a microwave burst that excites protons. More intense and frequent the pulse, more energy absorbed by the tissue, specifically at higher field strengths. The RF pulse is something that on almost every manufacturer you can determine. You have high, medium, and low options for your RF pulse type, which is going to change the amount of RF energy that pulse puts into the patient. In terms of SAR, again, the governor that the scanner has on it, when the SAR limits are approached, your scanner may ask you to switch from normal operating mode to first level. It can trigger scan delays, and it can ask you to make parameter adjustments to reduce the SAR. So this is, again, a rolling calculation of RF energy over time by watts a kilogram into the patient. So an example of this, at 3T with a TSE sequence, you may hit your SAR limits on that patient by scanner design very early in the exam, resulting in every scan having SAR adjustments like flip angle that could affect the image contrast. So what influences the specific absorption rate? Number one is field strength, by far the most important of these. At the higher field strength, higher SAR. For example, at 3T, you're at about 4 times the SAR power of 1.5. So as you go up in field strength, you are significantly increasing the amount of energy that you're putting into the patient, also increasing the risk of burn to the patient and induced current to the implant. Sequence type, the TSE sequence is going to have a higher SAR value because of the multiple 180 refocusing pulses that are going on the sequence. Every echo on the echo train is a refocusing pulse, added RF energy into the patient. Patient size is a factor in SAR. It's a little tricky because, again, most scanners are calculated just by watt per kilogram. Some now are taking into account the patient's height. Really, what you want to think of this as surface area. The actual SAR of a patient 6'4", 240 pounds is going to be very different than the SAR in a patient 5'4", 240 pounds. A patient with the larger surface area is going to attenuate more of that heat. So even though it is listed as just a watts per kilogram, can vary patient to patient on how that heat is absorbed. Scan parameters, lower TR, higher flip angle, higher TSE factor. Again, all of these are depositing more energy into the patient, increasing SAR. And again, the RF pulse type. So something to know that your RF pulse type is not just changing how much energy you're putting into the patient, but it's actually changing the shape of that RF pulse. So by going to a lower pulse type, a low SAR versus high SAR, you're also affecting image contrast. And we all would love a need for optimizing SNR without sacrificing image quality. knowing that in MRI, everything is a trading game. So by reducing SAR, we're typically increasing scan times and often sacrificing image contrast. This is where SwiftMR is going to come in a little bit later, and where our goal is going to be to optimize those scan parameters, keep the scan speed, and not lose image quality. Again, the higher field strength equals more SAR. Complex patients, your young pediatric patients, your elderly patients, and your obese patients do not thermoregulate the same as an average sized patient. These are patients where your SAR has to be more tightly restricted and watched to make sure you're keeping that patient safe. Obvious safety concerns. Some hospitals or other institutions may have a SAR limit on what the patient can actually absorb over a given time frame. And then there's patient throughput. In a world where we're all trying to see more patients, we're trying to go faster. Faster scans often lead to higher SAR, lower scans, lower SARs, longer scan times. Of course, TSE is the clinically preferred and most commonly used sequence in MRI. It has proven diagnostic reliability. It has more reproducibility and is less susceptible to artifacts. So we're going to try to use TSE sequences as much as possible, but they are going to come with a higher SAR trade-off. The SwiftMR advantage in using TSE sequences is because we are reducing the scan duration. You can maintain that full echotrain length. You can maintain the initial RF energy. You can reduce your SAR load by up to 40%, and you can remain in normal mode even when using slightly more aggressive scan parameters. So the practical parameter adjustments when doing fast spin or turbospin echo sequences, some lower SAR strategies would be to set your pulse type to low SAR, which is going to do things like increase your echo spacing, increase your echo train duration, and your TR. All of these are going to be increasing your scan time and possibly decreasing your image contrast. SwiftMR gives you the availability to reduce your echo train length, which is going to be done typically in the image protocol optimization anyways, but also the ability to lower your averages, increase your GRAPPA or your parallel imaging factor to shorten your scan time, and also shorten the amount of RF exposure to the patient while maintaining image quality. TR adjustment for SAR control again, minimum TR is what we're all going to usually scan with because we only want the amount of TR and the amount of time needed for the patient. But to keep a patient or an implant safe during an MRI exam, you're going to slow down. You're going to slow down by increasing your TR. Increasing your TR and increasing time. If that's kept as a constant, with SwiftMR, you're able to increase your parallel imaging factor, reduce your number of averages, and then compensate for that reduced signal to noise through our post-processing and keep the same image quality and image contrast with a reduced scan time and RF exposure. So we all know about normal and first level operating mode. Many facilities are going to have requirements for entering into first level or restrictions. For the most part, we're going to be operating in normal operating mode. Normal operating mode is the scanner's mode that basically protects the patient. It's going to keep the RF exposure at 2.0 watts per kilogram whole body and is the default mode for scanning. First level controlled mode is going into a 4 watts per kilogram for whole body, 3.2 watts per kilogram for the head. Not only will require some kind of documentation that you're allowed to go into first level, but it will also require you protecting the patient and protecting any of the patient's implants. For the most part, you're not going to be scanning implants in first level. But with SwiftMR, because the SAR and B1RMS is calculated RF exposure over time, you can typically maintain normal operating mode and faster scan times, keeping the image quality that you want while reducing the RF exposure to the patient. Also keeping in mind that many of these implants are scanning well below the limits of normal operating mode at 2.0 watts per kilogram. Many of the implants that we commonly are scanning are at half of that or less. So you can't just rely on the scanner's normal operating mode to keep you safe when scanning implants. So getting into SED, SAR equivalent dose or specific energy dose. This is something relatively new and something that we will see more of. As I talked about earlier, the SAR is kind of like the governor we put on the scanner to make sure you don't go too fast and you don't put your patient at risk. SED is going to be the regulatory information that comes through that is going to determine how much RF energy you can put into the patient over a given period of time. Let's say 24 hours. You may have noticed this on your scanner already, as some scanners out there will ask for you to slow down or suggest that maybe you've reached the total SED for the patient for over the given time period. Currently, you're able to go past this. In time, this may be a limiting factor or a stopping point for your scans. So as you're getting into those patients, an MS patient, let's say, where you're trying to do a brain, cervical, thoracic with and without contrast, you might be limited to an hour of scanning time, where this may be 2 appointments for the patient. Utilizing SwiftMR and adjusting your scan times by up to 40 or 50%, you'll be able to get more scans into the duration allowed with your SED. Currently, the SED suggested limit by Siemens is 14,400 joules per kilogram. you're given a display warning at about half of that. So again, where time and scanning becomes really valuable. The challenges of high SAR seems kind of counterintuitive, but we often build our scans with such a high energy output that the scanner governor will slow us down. So you may build a sequence that you think is only 75 to 90 seconds, but then the scanner's adjustment will take it out to 2 minutes. So high SAR can actually slow you down. Heat risk in vulnerable patients, the higher the SAR, the higher amount of energy you put into a patient, the more risk you are for overheating the patient, implant, or burning the patient's tissue. Image quality trade-offs, as we try to get away from high SAR, we're going to do things like decreasing our flip angle at the cost of image contrast and image quality. Implants, obviously, there's such a range of SAR requirements for implants that are out there, and our most concerning being our active or electronic implants. It's important to know what the guidelines are, and these guidelines can often be very difficult to meet. And again, SwiftMR allows you to meet the SAR conditions of these implants in a decently attainable scan time. A quick example of that, in the lumbar spine, an axial stack at a total of 44 slices, T2 weighted, on a 1.5 Siemens Esprit, we can attain in about 1 minute 56 seconds. Adjusting that same sequence for B1 RMS of 2.0 is approximately 4 minutes and 3 seconds. Attaining that same B1 RMS scan with acceleration techniques and SwiftMR to compensate for the signal noise and contrast to noise loss, we can run that 2.0 B1 RMS axial T2 stack in 2 minutes and 29 seconds with superior image quality and safety for the patient. Burn risk, of course, in the close proximity to the RF transmitter or around the implants. As your SAR goes up, your burn risk gets higher. This, again, is something that's kind of a function of your RF energy over time. So if our goal here is to maintain image quality, but have the ability to reduce now the time of exposure, we reduce the risk of burn. And then workflow and compliance burden. These implants can really be a killer in your busy schedule, often taking a 15-minute exam out to double that at 30 minutes. Using SwiftMR and acceleration techniques, you can keep the patient safe, you can meet the scan requirements of the implant, and you can do that all in a manageable scan time. Going back into that, many implants are SAR restricted. Pacemakers, neurostimulators, cochlear implants, your passive electronic implants are going to be our biggest concern, and usually your biggest limiting factors when scanning. They are almost exclusively going to be scanned in normal operating mode with given SAR B1 RMS thresholds. These restrictions can often cause delays or refusal to scan by the facility, either because they're unsure of how to get the sequence into the proper scan parameters, or because they just don't want to take the time to do the exams. And again, utilizing SwiftMR, you can keep the scanner in normal operating mode, keep a much more consistent scan time and image quality while keeping the patient safe. So in summary, SwiftMR's benefits for SAR management: it enables protocol flexibility, allows adjustment of SAR parameters, TE, flip angle, echotrain length, receiver bandwidth, while maintaining diagnostic image quality. Allows higher SAR sequences because, again, the B1 RMS or SED is calculated by RF power over time. If we are significantly shorting the scan time through utilization of AI and SwiftMR, we are reducing the overall exposure of RF energy to the patient. Kind of an analogy you can use on that is putting your hand over a hot stove. If you put it over there for a short amount of time, it's hot. If you hold it over there for a certain amount of time, there's a threshold that you can meet. So SwiftMR is going to allow you to put your hand into that hot stove and get the energy you need in a short amount of time. It's ideal for high-risk cases and high-field scenarios. Again, patients with active implants, patients that do not thermoregulate, you want to decrease their scan time and their exposure to the RF energy. SwiftMR allows you to do both of those. No compromise in diagnostic confidence because you are returning approximately 40% of signal to noise back to the scan. You can undersample the scan, reducing the scan time, and in the end, get an exam or an image with the quality and contrast and noise ratio that you want through SwiftMR processing. And you can maintain your patient throughput, not burdening your schedule with long exams and long repeats, trying to accommodate a patient with implants. In conclusion, SAR is a critical safety factor. Modern MRI, especially at 3T, especially in patients with implants or vulnerable populations. SAR is an important factor at all field strengths, and is important to know what the limitations are for the patient and the implant, but specifically at 3T, where the implant can almost immediately be in danger with a high SAR factor. Managing SAR often requires trade-offs. As given in my example of the T2 accident on the lumbar spine, we are typically almost going to double individual sequence time to stay within SAR, B1 RMS restrictions for an implant. Swift is the key to making that negotiation a little bit better in your favor, because while you still have to make some adjustments to reduce overall exposure, by greatly reducing the scan time, you're also greatly reducing the amount of RF energy deposited into the patient. And Swift Help and SwiftMR help. You can safely scan implants in thermally sensitive patients, improve throughput, scheduling flexibility, and you can reduce any compromise or trade-off in diagnostic image quality. And with SwiftMR, you don't have to choose between image safety and image quality. You get both proper RF exposure to the patient and image quality that you can trust. Thank you for your time, and good luck out there scanning implants.
Thank you, Chris. Now we'd like to open the floor for the Q&A session.